Hello dear students, welcome to the online lecture series of Design of Concrete Structure. In today's lecture, we are going to learn the design of staircase. The given thing is floor to floor height, size of the stair wall, live load, FCK, FY. Then step number 1. Step number 1 is to calculate the design parameter, which are KU max, PT max and RU max. Then step number 2 is we have to assume the rise, trade, also decide the width of the staircase. So this is our rise, this is our trade. Okay, we have to assume it depending upon which kind of building it is. Suppose if it is a public building, we have to decide it accordingly. In that case we have to keep the rise low and trade of higher direction, higher width, and vice versa. If it is a residential building or a bungalow, in that case we need to take this, we can increase the rise, also decrease the trade. Okay, then step number 3 is to calculate the number of risers and trade. Then step number 4, that is calculate the effective span depending upon the position of the beam. Now here we see the different effective span or the effective length. Okay, here if my beam is at this point and at this point, the effective length will be equals to L is equals to center distance between these two beam. In the same case, if my beam is shifted from this point to this over here, that is beneath the first light, and here the beam is shifted from this point to here, that is beneath the first light, starting of the first light, my effective length will be this much. Then the third case is if my beam is shifted over this point and this point, the effective length will be this way. And if we see page number 63 of IS 456-2000, you will be observing all this diagram on one page. Then after this effective span, which depends upon the position of the beam, we assume suitable depth on the basis of the serviceability criteria or the deflection, which is equals to D is equals to L effective upon L by D basic into alpha 1. Then we calculate the load on each flight. The first load which is acting on the flight is nothing but the self weight of the waste slab, which is equals to 25 into D into under root of R square plus T square divided by T. Now what is R and T over here? R is equals to size of the riser and T is equals to size of tread. Then the next is the self weight of the step, which is equals to 25 into R upon 2, which is in kilonewton per meter square. Then the step number 3 is the weight of floor finish load, which is equals to 1 kilonewton per meter square. And the fourth is the live load acting on the flight, which is equals to 3 to 5 kilonewton per meter square. Then what we do is we take summation of all these 4 loads, which is nothing but the self weight of the waste slab, self weight of the step, weight of the floor finish load and the live load. Remember that live load will also be changing according to the type of the building. If it is a residential building, it is 3 kilonewton per meter square. If it is a commercial building, that time the live load increases from 3 to 5 kilonewton per meter square. Now, as in the case of the slab, the same we do over here. What we do is we assume unit width of the staircase. By assuming the unit width of the staircase, what we do is we calculate the WU, that is the ultimate load acting on the flight, which is equals to 1.5 times into 1, which is nothing but the unit width, and WS, and WS is nothing but the total load acting on the flight. Now we will design the flights.